Hi guys, so now the next part of this is absolute value inequalities. So basically we're going to do the same thing, but if you remember with inequalities, it's going to be not necessarily equal to the line, it might be less than the line. So you might have some shading, right, to represent your solutions. Could also be equal to the line and greater than it, so you might have some solutions that are shaded like that. So we just want to remember, so how does this work? So a dashed line if we have less than or greater than symbols, and a solid line if we have less than or equal and greater or equal to symbols. Because remember, the equal to part means it's solid. Shade above for if we have greater or greater than equal to, and below the line or the absolute value function for less than or equal to symbols. So if we have this function here, my setup is still the same as what we just did. Whatever's in the absolute value, I set it equal to 0. And so I have x equals -1 is my vertex x value. Plug it back in and I get 0. So my vertex is at -1, 0. So the only thing I have to do is find some points around it. So if I plug in a -3, I get a 2. If I plug in a -2, I get a 1. If I plug in a 0, I get a 1. If I plug in a 1, I get a 2. So then we have our 5 points right here. I already plotted them. And all we need to do is graph it. I wanted to use kind of a lighter color. And we have to think about, is it dashed or solid? Oh, it's less than, so it's dashed. Right, so you're just going to have little tick marks, dash, all the way through, doing the best you can with online tools, if you're using online tools. And then less than, if you like to test points, pick a point that's easy to see. 0, 0 is underneath here, so I can check 0, 0. Is 0 less than 1? Yup. So because underneath is a solution, all of this is a solution, right? So I have my shading is going to be all of this space here. Kind of looks like a beard. So all of this space here, if I had a color pencil, I'd do a really nice job of coloring in all this space. Now it looks like a creepy smile. All right, so if we continue on for a problem like number 2, just wanted to show you that kind of case. So we have x minus 5 equals 0 to find where the vertex is. It's at 5, and then when I plug that in, I get -2. So my vertex is over here at 5, -2. And then let's plug in the other values and graph them and all that fun stuff. So 3 minus 5 minus 2, so I get 0. 4 minus 5 minus 2, I get -1. 6 minus 5 minus 2, I get -1. 7 minus 5, absolute value of that, minus 2, I get 0. So then I'm plotting my 5 points. Oopsie. All right, plotting my 5 points. So I have my vertex already. I've got the other points. Now, is it dashed or is it solid? Well, it's equal to the line, so it's going to be a solid line. That. And like that. Now, the last thing is, do I shade above or below? And I can check 0, 0 to see if it's not true, but I would imagine above the line is going to be over here. So 0 is greater than 3. When I plug in 0, I get 3, and that's not true. So because this is not true, I'm going to be shading all of this space here and above that. Okay. I wanted to show you this one, number 4, and that'll be it. Even though these look more challenging, they're all kind of the same idea as what we've been doing. So 2x equals 0, so x equals 0 for my vertex. Plug that in, I get a 3. And then let's plug in the surrounding values. So I have -1 and -2 and 1 and 2. So -1, when I plug that in, I get a 1. Keeping it orange here. When I plug in -2, I get -1. When I plug in 1, I get 1. And when I plug in 2, I get -1. All right, so now let's plot these 5 points. -2, -1. -1, 1, 0, 3, 1, 1, and 2, -1. So now my V is upside down. Why is it upside down? Oh yeah, because there's a negative out front. Is it solid? Yes, it is. So from this point, drawing as straight as I possibly can. From this point, drawing as straight as I possibly can. And then, am I shading? Where am I shading? So it's a less than line, which could be confusing where that is. Let's check 0, 0. I think it's going to be here, but let's see. 0 is less than, plugging in a 0 is less than 3. So is 0 less than 3? Yeah. So because this is a solution, that means this whole space is a solution. Okay. So shade in all of this space here. Awesome. So that's what I wanted to show you today, all about inequalities. It's not much different than what we did in the last video with these problems here, okay? All right, cool.